Lesson 12.8, Probability Distributions. In this lesson, you will learn to find probabilities by using random variables and also find expected value of a probability distribution. Vocabulary for this section is random variable, discrete random variable, probability distribution, probability graph, and expected value. Okay, so first thing we want to look at is random variables. The owner of a pet store asked customers how many pets they owned. The result of this survey are shown in the table. Find the probability that a randomly chosen customer has 2 pets. So, if we're looking at this, for the number of people asked, number of customers, 33 said they have 2 pets. So we're going to have 33 out of the whole amount. So to find the whole amount, we want to add all of them up. So I'm going to do 3 plus 37 plus 33 plus 18 plus 9. And so I'm going to get 33. 33 out of a total of 100. Okay, so this as a probability, and a lot of times probability is written as a decimal. So that would be 0.33. Okay, and that would be the probability of choosing somebody that has 2 pets. Okay, in this one we're going to find the probability that a randomly chosen customer has at least 3 pets. So in this case, we're saying we're looking for the probability, which we say with a P, of the number of pets being less than or equal to, greater than or equal to 3. So at least means that they would have either more than 3 or more. So we want the number of pets to be greater than or equal to 3. So in this case, equal to 3 or greater than 3, that's going to be the people who have 3 or 4 pets. So again, this total was out of 100, so this probability is out of 100. And we have 18 and 19, or 9. 18 and 9 together gives us 27. So this probability, 18 plus 9, so this is 27 out of 100, which as a decimal is 0.27. Okay? You guys give this one a try. And this one. Okay, so we want to look at properties of probability distributions. The probability of each value of x is greater than or equal to 0 and less than or equal to 1. So again, we're saying decimals. So it has to be greater than or equal to 0 or less than or equal to 1. You can't have a probability of 1.5 because that's outside of the range. You also can't have a negative probability. Okay? And the sum of all the probabilities in the distribution, when you add them all up, it will give you 1. So we want to be able to look at a problem and see if this makes sense as a valid probability distribution. So first thing we want to do is we want to look and see if all of our probabilities are between 0 and 1 or equal to them. So nothing greater than or less than what I'm looking for. So this one's okay, that one's okay, that one's okay, and that's okay. So that's the first thing we want to do. So far we can say all values of px are between 0 and 1. So we're okay there. The second thing we want to look for is that the sum is 1. So we want to show that 0.29 plus 0.26 plus 0.25 plus 0.2. Hopefully when we add those all up, we get 1. Okay, so when I add it all up, I do indeed get 1. So this one is valid because it meets those 2 requirements. Okay. The second part of this says if a student is chosen at random, what is the probability that he or she is in grade 11 or 12? So remember from last section, when we have an or, when we're finding the probability of an or, we just add the two probabilities together. So they're saying the probability of being in 11th grade is 0.25. So the probability of 12 is 0.2. So I add them together, and my total probability of being in 11 or 12th grade is going to be 0.45. Okay. The last part, it says make a probability graph of the data. So what a probability graph does is it takes what I'm looking for, my x, so this is like a p of x, and this is x, and I graph these. I make a bar graph. So I'm going to have 9, 10, 11, 12. And when I do this, I'm going to have on my axes, we'll say 0.1. Let's go a little bit bigger. We'll say this is 0.1, so then this would be 0.2. So 0.2 is going to come, sorry, hang on. Let's say 0.1 here, 0.2, 0.3. So for 0.29 for 9th grade, I'm going to draw a bar graph up to 2.9. For 10, I'm going to do up to 2.6. A little bit lower. For 11th, I'm going up to 0.25. And then for 12th grade, I'm going up to 0.2. And that's how you do a probability distribution graph. Okay, so there's one that looks a little bit nicer. They did a broken graph here to make it all look nice. But, okay, so you guys do this one. All right, so expected value of a discrete random variable. So the expected value of a discrete random variable is the weighted average of the values of the variable. It is calculated by finding the sum of the products of every possible value of x and its associated probability p of x. So like when we had our tables, x and p of x, so if I had like 5 and the probability was 0.2 and then like 4 was 0.8, my expected value is going to be 5 times 0.2 plus 4 times 0.8, and that gives me e of x. Okay, so let's do this with a little bit more complicated things. So the first thing we have to do is we have to make a probability distribution. So in this case, we have the probability more as like a fraction, 1 in 5,000. So in order to do that and get this into a number here, probability, I'm going to do 1 divided by 5,000. And I get 0.2 like that. Okay, so when I do this, I'm going to keep doing this. So I'm going to do 1 divided by 50,000, and I get 0.00002. And if I were to do 1 in 20,000, sorry, 1 in 500,000, be 1, 2, 3, 4, 5 zeros, and then a 2 for 1 in 2 million. 1 divided by 2. 1 divided by 2 million is 0.1, 2, 3, 4, 5, 6, and then 5. Okay, so if I'm doing this, and then when I have 0, this. So 0 represents in this one all of the values that don't fit into these categories. So in a probability distribution, remember everything has to equal 1. So I'm going to do 1 minus each of those other values I have. So 1 minus 0.0002 minus 0.0002 minus. Okay, and what I get is 0.99977775. All right? And so that's my probability distribution. The next part is to use this probability distribution to calculate the expected value. So remember, it's this times this, plus this times that times that, that times that, and that times that. Okay? So when I do this, I'm doing 500 times 0.0002 plus 5,000 times 0.123 plus 20,000 times 0.12345 and 50,000 times 0.12345 Okay, and then 0 times anything is just going to be itself, so I'm not going to write that one. But anyway, so you're going to do all these. 500 times 0.002 is 0.1. Okay, so I'm going to go through and calculate this and pause the video right here for a sec. Okay, so when I do this, I get 1.165. So that would be the expected value. So if people are paying $5 to enter this and they're only expected, this is the expected value that each person would get back, then the people who are running this contest would stand to make, 5 minus, okay, 5 minus 1.156. 165. So 5 minus that. They would expect to make $3.8 for every entry that they made. Oh, which is what I just did. So I just interpreted that was part C. All right, you guys try this one. And that is lesson 12.8.